So in today's practice, we're going to find out that we have to use some placeholders. What's the first thing we always did yesterday before we added or subtracted our polynomials? Always. Change the subtraction within the polynomials themselves and to add the opposite. So 2x cubed plus x squared plus negative 3. And if you want to slip a 1 in front of the x squared, you can do that also. And then in our other one, we have one subtraction also. We'll change that to add the opposite. And again, we can slip in a 1 if we want in front of the x because it's really being multiplied by 1. And now we're ready to set up our addition problem. Let's go do our vertical first. Okay, now when we're writing this one down today, be careful. Notice something about this first one. It has an x cubed, has an x squared, but what doesn't it have? X. Doesn't have any x's, does it? So we're going to make room for those x's. We're going to have a placeholder for those x's. So we're going to have 2x cubed plus 1x squared plus how many x's? 0. 0 x's. And then plus our constant negative 3. So we're putting a placeholder in there. Because when we add vertically, we need the like terms lined up in columns. So now we'll go and put our second polynomial. We'll line up underneath the like terms. Do we have any x cubes in our second polynomial? No. No. So we could put 0x cubed so we have something to fill the spot. We don't have to necessarily because it's in the first position, but we can. And then we have 4x squared that'll line up underneath the other x squared. A negative 1x to line up under the other x's. And a plus 1 to line up under the other constant. So go ahead and add that up. Clean it up. How would it look in an answer bank? How will this look in an answer bank?
2x cubed plus 5x squared, subtract 1x, subtract 2.
Even better yet, cleaned up even more. Subtract not 1x, but just x. They're probably not going to have that 1 in there in the answer bank.
Subtract 2.
Subtract 2. Here's our cleaned up answer, how we would actually see it in an answer bank. Okay, these are the ones that you actually might like using the horizontal format for better when the polynomials their terms don't match up, the degrees of each of the terms don't match up. The horizontal might be the one that you like better. Here.
You get a different answer.
When you do it horizontally? Okay.
No, you don't.
Well, let's check it out. We're going to all do it anyway, so let's do it. Okay, so we're going to do the horizontal format now. So we have since it's all addition now, we can just go right to grouping the terms together that belong together. So we have maybe the first thing we should do is just write these down here so we have them to look at. And we can ditch the parentheses because everything's addition. So okay, we can ditch the parentheses because everything was addition. We just write them all down, our big string of them. And now we're just going to regroup them. So we had 3 terms in the first one. We have 3 terms. 3 terms in the second one. We have those 3 terms. Who's going to be first? When we think of standard form, which term should we start with? We're going to reorder them. 2x cubed. Are there any other x cubes? Remember when you do it this way, it's kind of nice to cross them out so you don't leave anybody out. Any other x cubes?
Yeah.
Any other x cubes?
No. X squared.
Okay, but we get some x squared. We got 1x squared and 4x squared.
And then negative
would be next?
Alright, 0x.
No, we don't need placeholders. We don't need placeholders when we do horizontal.
-1x.
Plus negative 1x.
Then plus 3, -3.
Don't have any other x's, so now we can go to the constants.
Then plus 1.
So we had 6 terms. When you do it horizontally, you don't need placeholders. So we had 6 terms. We still should have 6 terms. All we've done is change their order. 1, 2, 3, 4, 5, 6. We're good. So now we're going to say which ones can be put together. These guys can, and these guys can. So we get 2x cubed plus what? What's 1 and 4? 5. Don't have anything to combine with that negative 1x.
Negative 2.
And then plus negative 2. Looks exactly like it did when we did it vertically, doesn't it? We just have to clean it up again. So 2x cubed plus 5x squared. We don't need to change addition. Ditch that addition sign, make it negative, or subtraction I mean, and the 1 doesn't need to be there anymore. Get rid of the addition sign, let that negative become subtraction, and 2. So, did you find your mistake, Ellie?
Yeah.
Okay. Okay, any questions? So which one do you like better when there are missing terms?
Vertical.
You still like vertical, you like using
Horizontal. I've always liked horizontal.
Okay, so do we have to use placeholders in horizontal? No. We need them in vertical, but we don't in horizontal. So you just, and again, you get to decide when you're adding and subtracting these, which ones you want to do. But okay, what's going to be our first move here? And number 2?
Add the opposite.
Add the opposite where?
Inside the
Only inside the polynomials themselves, inside the parentheses. So we're going to have x squared plus negative 1. Don't do anything with that subtraction sign yet. 3x plus 2 can stay as it is. And our last polynomial is going to become 2x squared plus a negative 4x. Okay, next move we're going to do is we're going to get that subtraction out of there. Okay, so we're going to rewrite it. X squared plus negative 1 does not need to change. It's not what's being subtracted. But we want the subtraction to change to addition. So what did we do when we changed subtraction to addition?
Change all of them.
With the polynomial behind it, only this polynomial, 3x plus 2, has to change to its opposite, not the other polynomial. 3x plus 2 is the one being subtracted, so we change its terms to their opposite. Haley?
Can't you just do it all in one step? When you just change the opposites right away instead of doing an extra step?
If you're successful. If you're successful. Sometimes if students try to change, subtract. Now, here's where it gets a little tricky. If this had been maybe 3x minus 2, that's where students make the mistake when they try to change both this subtraction and this subtraction at the same time.
You do
So,
one in the parentheses first and then you fix it. You go back to do the second. So you just have to write all of them.
so you don't. So you're trying to avoid having to do it twice. You're saying.
Yeah.
Okay. So what I'm saying though is, you can do it just once as long as you're successful. As long as you find that you're getting the right answer the only time, that works for me. But if you're not, then the best thing to do is just to take that extra step to guarantee yourself, some better success with it. Okay, and this other polynomial is just being added, so it does not need to change. It just is going to stay like it is. The only one that needed to change was the one that was being subtracted, the one in the middle. Okay, now, when we add these vertically or horizontally, we're going to do the vertical all in one addition. So we're going to look at them and we're going to say, what's the highest? This one's second degree, first degree, second degree.
So can you put on the first one first and the third one?
You can, but you don't really need to. What I'm saying is, we got to decide if this one needs a placeholder or not at the beginning. But since the second degree is the highest degree, we don't need to worry about putting a placeholder for the x cubes because neither of these other ones has any x cubes, does it?
The third one does.
Has x cubes?
It's 2x cubed.
No,
Squared.
it's square.
Square?
Oh, square, not
Okay.
cubed.
So we're going to say x squared, but it doesn't have any x's, so we need a placeholder for the x's, don't we? So plus 0x plus negative 1. What term doesn't the second polynomial have?
X squared.
Doesn't have the x squared, so we're going to put a 0x squared plus negative 3x plus negative 2. Which term doesn't the third one have?
The
Last one.
What's that called?
New.
Constant. Okay, so 2x squared plus negative 4x plus what? 0. Okay, so we're doing the vertical format where we are going to have placeholders. And we're just going to add all three of these at the same time. Okay? A 1x squared plus a 0x squared plus a 2x squared. What do we have? 3x squared. A 0x plus a negative 3x. What's that?
-3.
Negative 3. A negative 3x plus a negative 4, what's that?
-7.
Negative 7x. Negative 1 plus negative 2. Negative 3 plus 0.
is it negative 3?
Negative 3. Okay, let's clean it up. What's this cleaned up?
3x subtract 7,
3x squared subtract 7x
subtract 3.
subtract 3. Okay, now when we do it horizontally, again, do we need placeholders? No. Okay, let's do it. Everybody do it though. I want it in your notes. I want you to put down we can ditch all of the parentheses because we have done all the subtraction, get that changed. So we can just write all of them down. And then we can rearrange them. So, I want you to rearrange those. There are 1, 2, 3, 4, 5, 6 terms. There should be 6 terms in your rearrangement also. Where's your rearrangement? Oh, you're doing the underlining.
Yeah.
I'll show you that.
I can't rearrange them. That's in my head.
That's okay. Rearranging, put them in the groups that they can be in. Cassidy, you want to do this for me? Really? I'm just gonna lay the pen on the table. Also, when you move them down here, you just rearrange them, right?
Yeah.
And then when you rearrange them, you put the extras behind the constant. And then now you
Rearranged again.
rearrange it again, get it in standard form.
Do you want me to change color for the next one?
Sure. Be awesome.
Show me what you were talking about.
You did it with us, okay?
How do you raise text?
So you had, when you did it all in one step, did it look like this when you were done? Did yours look like ours? So you could make it look like that right this second. Yes. Okay, thank you, Cassidy. Okay, so again, when we do horizontal, sometimes horizontal is nice in the fact that we don't have to add extra stuff in. We don't have to have those placeholders involved. But then we also have to be really careful when we do horizontal, not to leave out any pieces either.
I don't like we get all.
You just kind of count up all the terms of the polynomial. 1, 2, 3, 4, 5, 6. That means we better have 6 in our, before we start combining like terms. Okay? Anybody have questions? Because today you're going to come across somewhere you're not going to have some of the terms that would be able to be combined with others from the other polynomials. Okay, let's go to the back side where we're going to solve an equation. Because you're going to be doing some of the, you're going to do that in your homework today. So let's solve an equation that has polynomials in it. Okay, our first move on number 3 is we got to get, if we could get the right side simplified, then we can go to work solving from there. Now you haven't solved any equations that have anything more than to the first degree in them. So hopefully this is going to work out nicely for us. Okay, so the first thing we're going to do is like we would do just on the front side. We're going to change any subtraction we have inside the polynomials to add the opposite. So the only thing I'm doing in this step, I had one subtraction to change, a lot of writing to do for one subtraction change to add the opposite. That's the plus and negative 2 at the end of that first polynomial. Okay, now we're going to change that subtraction. B squared equals 3b squared plus 4b, that's going to stay plus 7. But now we're going to change this to add
Negative 2b.
negative 2b squared. What next? Plus,
Plus negative 5b plus 2.
see, I made that look like a 6. Plus negative 5b. I don't like b's. They look, my b's look like 6s all the time. Plus what? 2. Plus 2. Okay. Okay. Now we're ready to this one because we're solving the equation. You can veer off to the side and do vertical, or you could just stick with saying I want to keep the whole equation together, so I'm going to do horizontal this time. So
What's the b to the second? What's that for?
okay, that's part of our equation right now. So just
We're
let
supposed to be solving.
it keep coming along. We're solving this equation for b. Think we're going to be able to do it?
Yes.
Okay, but so far, what have we done so far? Have we really done any solving yet?
No.
This has all been simplifying. We're just simplifying so far. Okay, so right now I want us to keep simplifying. I want us to combine like terms. In other words, let's add these together. So let's do the horizontal way. 3b squared plus negative 2b squared.
Can I do it the vertical way?
Go ahead. Plus 4b plus negative 5b. So I've taken my b's, I've got my b squared, I've got my b's, I just need my constant, plus 7 plus 2. So I'm doing it the horizontal format. If you want to do it the vertical, go ahead, and then we'll bring that b squared down on the other side when you're done.
I got it to the answer, but I don't think I did it right. I still haven't solved it.
Okay, so all we're doing right now, you guys, is the same thing we've been doing, except we have a b squared equals hanging out with it. And we just keep bringing it along. We're still just subtracting polynomials over here. We're simplifying this equation right now. So let's just keep going. B squared equals, what's this become?
It becomes negative, or 1b.
That becomes a b squared, right? 1b squared.
Squared.
Okay, plus, what's this become?
Negative 1b.
Negative 1b. Plus
9.
9. Okay, we're going to clean this up before we even continue on. We're going to still just keep doing what we've been doing. We're going to say, okay, now let's clean up that simplified side. What would it actually be cleaned up in an answer bank? Haley?
b to the second subtract b plus 9.
Okay. Can we do any other simplifying? Is there anything we can do on that right side? Can b squares be put together with b's? No. Or 9s or no? Okay. So now we're ready to solve. We are finally to the step that says, okay, do the same thing to both sides. Well, the first thing I'm going to want to get rid of is, Jossie, will you stay with us, please?
Yeah.
Thank you. First thing I'm going to get rid of is the b squareds, because you know what? I've never learned how to solve b squared, so why don't I try to get rid of them? So I'm gonna say, well, if I want to get rid of this b squared over here so I can get b alone, I'm gonna just subtract b squared from both sides. Can we do that? Is that legal?
Yeah.
Okay, do the same thing on both sides, it's okay, right? Okay, well then what do we get? What do we have on the left side? What's b squared take away b squared?
0.
0. So 0 equals, well, those are gone, so we have
Negative b plus 9.
negative b plus 9. What do you want to make as your next move?
Subtract 9.
Subtract 9, okay. Subtract 9 from both sides.
Now you got negative 9 to go to b.
So negative 9, 0 take away 9 is negative 9.
Negative,
These guys are gone, I have negative b.
and then divide both sides by negative 1.
Now we're going to divide both sides by negative 1. Okay, negative 9 divided by negative 1. Negative b divided by negative 1.
B equals 9.
This is b over here, and negative divided by negative is a positive. 9 divided by 1 is 9. B equals 9. We solved it. So
This is
pretty.
like stuff we learned a long time ago.
Yeah, well, isn't that amazing? We're learning how to solve equations before it's coming in useful now too.
Yeah.
Along with now we're also adding some, we have some more complicated simplified, but we know how to do it now. Okay.